Picture the summer of 1969. Dealership lots across America overflow with big block muscle cars, raw, thunderous, and intoxicatingly simple. Chevrolet had practically invented the formula. The 427 cubic inch V8 was king, and nobody questioned it. Nobody, it seemed, except a quiet group of engineers deep inside GM's technical divisions. While the rest of America was counting cylinders in 8s, those engineers were secretly counting 12s. A V12 Chevrolet. Say that phrase and watch any gearhead pause. V12 engines didn't belong in American muscle cars. They belonged in Italian exotics, British Grand Tourers, and Le Mans prototypes. They were expensive, complicated, and almost defiantly un-American in concept. Yet documented evidence suggests that General Motors engineers didn't just sketch the idea, they reportedly built hardware. So why would the company that perfected the brutal, brilliant big block V8 suddenly chase 12 cylinders? And how terrifyingly close did this secret machine actually come to reaching the showroom floor? To understand why a secret V12 project even existed, you first need to understand just how completely Chevrolet owned American performance during this era. The late 1960s weren't merely a golden age for muscle cars, they were an arms race with sheet metal and gasoline. Ford had the 428 Cobra jet. Dodge was stuffing 426 Hemis under hoods barely wide enough to contain them. Pontiac was extracting monstrous power from its Ram Air engines. Every single model year brought bigger numbers, wilder options, and increasingly unhinged factory performance packages. And standing at the center of that beautiful madness was Chevrolet. The small block V8 had already rewritten the rules of affordable performance. Then the big block arrived and tore those rules completely apart. The 396, the 427, the legendary 454, these weren't merely engines, they were declarations. Powering the Camaro, the Chevelle SS, and the Corvette, Chevrolet's V8s represented the absolute pinnacle of American muscle car philosophy. Massive displacement, thunderous torque, and gloriously uncomplicated brutality. No exotic metallurgy, no complex engineering compromises, just cubic inches and raw, unfiltered power. Which makes what happened next almost impossible to explain, because somewhere inside General Motors, an engineer looked at the most dominant performance formula in America and decided it simply wasn't enough. But beneath the glory, cracks were beginning to show, not in sales figures, but in the physics itself. Pushing a big block V8 beyond certain thresholds meant confronting some brutally inconvenient engineering realities. Massive displacement generated massive heat. Cooling systems strained under sustained high-performance conditions. Vibration became increasingly difficult to manage as displacement climbed and reciprocating masses grew heavier. And perhaps most critically, airflow efficiency deteriorated at higher RPM ranges, the very territory where serious performance engineers wanted to live. The big block was an extraordinary hammer, but not every performance problem was simply a nail. European manufacturers had quietly understood this for decades. Ferrari, Jaguar, and various racing constructors had demonstrated that 12 cylinders, smaller individual combustion events spread across more pistons, produced something a V8 fundamentally struggled to replicate. Silky, seamless power delivery with an extraordinarily high ceiling. Smoother combustion cycles, better mechanical balance, power that built progressively rather than arriving in one violent, almost uncontrollable surge. Inside GM's engineering divisions, certain ambitious minds began asking a genuinely dangerous question. What if you combined European cylinder sophistication with pure American cubic inches? What if Chevrolet's next performance breakthrough didn't involve a bigger V8 at all? What if it involved abandoning the V8 entirely? General Motors in the late 1960s wasn't simply a car company. It was arguably the most powerful and well-funded engineering organization on the planet, and it knew it. GM's internal culture actively encouraged experimentation that never appeared in any press release or shareholder report. Engineers were given latitude to explore concepts considered wildly impractical by conventional standards. Radical ideas weren't automatically killed. They were tested, documented, and occasionally developed far further than anyone outside those walls ever suspected. The V12 concept reportedly emerged from an elegantly simple, almost obvious starting point. Rather than designing an entirely new engine architecture from scratch, certain engineers began exploring what happened when you effectively married two existing Chevrolet cylinder banks into a single, unified power plant. Two small block V8 configurations ingeniously combined, sharing a common crankshaft. Familiar components, extraordinary results. Prototype engines began materializing inside GM's experimental facilities. These weren't showpieces or publicity exercises. They were genuine working platforms designed specifically to study airflow dynamics, power ceilings, and mechanical refinement under real operating conditions. What those engineers discovered surprised even them. They hadn't merely built an oversized curiosity. They had accidentally created something that delivered thunderous American displacement alongside a smoothness and operational refinement that no production V8 had ever approached. The big block roared. This thing simply surged, endlessly, effortlessly, and with deeply unsettling capability. But laboratory results only tell part of any story. The real reckoning always comes when experimental hardware meets actual performance testing. When those engineers finally committed their V12 concept to actual metal, the approach they chose was characteristically American: pragmatic, resourceful, and quietly brilliant. Rather than embarking on an entirely clean sheet engine design, the reported configuration leveraged something Chevrolet already possessed in abundance: one of the finest small block V8 architectures ever conceived. The fundamental concept involved grafting two cylinder banks, each derived from familiar small block geometry, onto a single, specially fabricated common crankshaft. 12 cylinders, one unified power plant, built substantially from components that Chevrolet's own production lines already understood. The elegance of this approach cannot be overstated. Engineers weren't gambling on entirely unproven metallurgy or untested tolerances. They were extending known, trusted architecture into genuinely unexplored territory. Displacement estimates for various reported configurations were, by any measure, extraordinary. Combining two small block-derived cylinder banks potentially pushed total swept volume into ranges that would have made even the most aggressive big block V8 appear almost modest by comparison. Early theoretical horsepower projections suggested output figures that no American production engine had yet publicly achieved. But 12 cylinders introduced engineering complexities that couldn't simply be borrowed from existing parts bins. The crankshaft alone represented a significant challenge. Longer, heavier, and subjected to entirely different harmonic stresses than any V8 equivalent, it demanded new thinking around torsional rigidity and bearing support. Oiling systems needed fundamental rethinking. 12 pistons, 12 connecting rods, and a vastly extended crankshaft required pressure and volume that conventional V8 oil pumps simply couldn't guarantee under sustained high-performance conditions. Cooling presented its own serious arithmetic. More cylinders generated more combustion heat distributed across a longer, more complex engine bay footprint. Thermal management that worked beautifully on a 427 cubic inch V8 became considerably less straightforward when extended across 12 cylinders of comparable individual displacement. Fuel delivery and ignition systems faced similar recalculations. Feeding 12 cylinders evenly, maintaining consistent mixture distribution across a longer intake manifold, required engineering solutions that carburation technology of the era struggled to answer cleanly. Yet, despite every complication, Early test stand results were, by reported accounts, genuinely remarkable. The engine didn't merely run, it ran with a smoothness that reportedly stunned engineers accustomed to the inherent mechanical harshness of big block V8s. Power built progressively across the entire RPM range, without the abrupt torque surges that made big blocks simultaneously thrilling and occasionally treacherous. On paper, and apparently on those test stands, Chevrolet had potentially created the most devastatingly capable American performance engine ever assembled. The question was no longer whether it could work. The question was becoming something far more complicated and far more dangerous than pure engineering. Dyno cells don't lie. And what Chevrolet's instrumentation was reportedly revealing about this experimental V12 was, by any objective measure, extraordinary. Where big block V8s delivered their power in characteristically violent, dramatic surges, intoxicating certainly, but fundamentally raw, the V12 produced something engineers rarely encountered in American performance testing: smoothness. Progressive, relentless, almost unsettling smoothness. 12 evenly spaced combustion events per crankshaft revolution created a mechanical harmony that no 8-cylinder configuration could mathematically replicate. The implications were significant. Smoother operation meant reduced parasitic vibration losses. Less destructive resonance meant the engine could theoretically chase higher RPM ceilings without tearing itself apart. And more cylinders meant superior airflow distribution, each individual combustion chamber processing smaller, more manageable charges with greater efficiency than the enormous bores of a big block demanded. Projected horsepower figures, even by conservative estimates, were genuinely staggering for the era. Consider what this engine represented, installed inside a production Corvette or a purpose-built Camaro variant. Not merely another muscle car, something categorically different. A machine occupying the same rarefied territory as European Grand Tourers, but delivering it with unmistakably American displacement and aggression. Chevrolet had potentially engineered the most sophisticated American performance power plant ever conceived. But the dynamometer results, however impressive, were becoming increasingly irrelevant. Forces far beyond the engineering department were already gathering, and they had absolutely no interest in horsepower figures. Brilliant engineering, unfortunately, has never been sufficient reason alone to build a production automobile, and Chevrolet's V12 was about to encounter a set of obstacles that no dynamometer result could overcome. The financial arithmetic was brutal and immediate. American muscle cars existed within a delicate economic equation: relatively affordable vehicles delivering extraordinary performance through mechanically straightforward engineering. A V12 shattered that equation completely. More cylinders meant exponentially more machining operations, more precision components, more assembly complexity, and dramatically higher manufacturing costs. The buyer who could stretch to a Chevrolet SS or a base Corvette almost certainly couldn't absorb the pricing that a production V12 would have demanded. Then came the packaging reality. Every existing Chevrolet performance platform, the Camaro, the Corvette, the Chevelle, had been engineered around V8 dimensions. A V12 was fundamentally longer and considerably heavier. Accommodating it would have required expensive, time-consuming platform redesigns that management could never justify against uncertain sales projections. But the cruelest blow came from outside General Motors entirely. The early 1970s arrived with devastating speed. Insurance companies began systematically penalizing high-performance vehicles. Emissions legislation tightened with increasing aggression. Then the 1973 fuel crisis detonated across the American automotive landscape like a bomb, virtually overnight, rendering high-displacement performance engines not merely impractical, but culturally toxic. Chevrolet hadn't simply missed a market window, the entire market had ceased to exist. Some engines define eras, others define possibilities. Chevrolet's experimental V12 belongs permanently, fascinatingly, to that second category. What those engineers created inside GM's experimental facilities wasn't merely a curiosity or an overambitious sketch that never left the drawing board. It was functioning, breathing proof that American performance engineering during the horsepower wars was capable of extraordinary creative courage, willing to chase genuinely radical ideas even when conventional wisdom offered perfectly adequate answers. Imagine the alternative history: a V12-powered Corvette arriving at peak muscle car era, combining European sophistication with American displacement brutality. It wouldn't simply have been another performance car. It would have redefined the entire conversation about what American performance could mean, repositioning Chevrolet not merely as a muscle car manufacturer, but as a legitimate competitor to the world's finest performance machinery. Instead, the project quietly disappeared into GM's engineering archives, buried beneath the wreckage of an era that collapsed faster than anyone anticipated. But forgotten doesn't mean unimportant. Every surviving document, every reported dyno figure, every whispered account from engineers who were actually present reminds us that automotive history isn't only written by the cars that reached production. Sometimes the most powerful engines are precisely the ones that never did.